So from the description first, if some of you read description, you know, pretty long, right? It looks pretty long, yeah. But actually, you know, I plan to do it in this way, yeah, because I will give you a lot of sample code. Yeah. So most of the features, I will provide sample code. Yeah, yeah, because for the remaining of the semester, we do not have much time. Yeah, so we have a little more than 1 month to complete this project. So not much time, but at the same time, you need to do your homework assignments, and you also need to prepare for the final and doing the final. So a lot of things you need to do. Yeah. So I do not want to use too much time. Yeah. Let you work too much, do too much work. Yeah. So I want to reduce your workload a little bit. Yeah. Yeah. So that I will provide you a lot of sample code covering most of the features. So as a learning process, yeah, because I feel some of the students may not be familiar with PHP. Yeah. So I provide you sample code, and then I explain the code so you can get started quickly. Yeah. So by learning, understand my sample code, yeah, the features, how I implement the features, so you, with that understanding, so then I just ask you to implement one main feature. Yeah. All right. So here, university database, I already uploaded. Remember, I give you the example, university view example. Yeah. When you run it, so you need to use that university database. Yeah. So you use the same database. Yeah. All right. So the feature here, first, enter data. Yeah. But there are two versions, enter data. The first version, single row version. Yeah. Single row version, yeah. Every time you enter one row of data for one of the 5 tables. Yeah, we have 5 tables. Yeah. So you can use the, hyperlink. So get to any one of the 5 tables. Then, so you use this simple interface so you can enter one row of data. Yeah. So this feature, I will give you the sample code. Yeah. Sample code contains this feature. Okay. Yeah. You just learn, get familiar with the basic features. Yeah. All right. Then, after that, there is the second version of and data input. That's the multi-row version. Not a single row, multi-row. Yeah. So this is the main feature you need to implement in this project. My sample code does not contain this feature. So you need to write your own code to implement this feature. Yeah. All right. So multi-row, yeah. First, you need to modify the interface, yeah, because this interface does not support multi-row, okay? Only single row. Yeah. So then, you need to modify your interface. Yeah. All right, so that part, yeah, so here, yeah. Actually, in my sample code, so you modify from my sample code, yeah. Yeah. So this enter button, and you need to add this part. My sample code contains this enter button, yeah. But you modify code, you add a text field, small text field after the enter button, then row. Enter number of row. By default, it's one row. So 1 is there, that's the default value, okay? Yeah. So if you do not change anything, you do the single row input. Yeah. But you need to write the extra part, yeah, the new part. The new part is you can enter a new row number in this small text field, like this one. Yeah. Here I use example, enter 4 rows. Yeah. The row number should be between 1 and 6. 1, 2, 3, 4, 5, 6. Yeah. Yeah. If the number greater than 6, then you use 6. Okay? Yeah. If the number less than 1, you use 1. Yeah. 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 But at the end, it should be one of the numbers between 1 and 6. Yeah. So here I use 4 as the example. After you type 4 there, then the interface should be changed accordingly. First, that single version row, you need to change to rows plus add S. Okay, a small change. 4 rows. Yeah. So when the row number greater than 1, so you change that to rows S. Yeah. If you change the row number back to 1, so then you change it back to row, no S. Yeah. That's the little thing. Yeah. But that's, you need to do more. So if you enter 4 row number, then at the same time you need to modify, you need to provide 4 rows of text fields for the multi-row input. Yeah. Each row corresponds to one record. Okay. Yeah. Yeah. So that's the UI change, user interface change. Okay. So you use JavaScript to do it. Okay. Yeah. Put a number. So you use JavaScript. Make the change. Yeah. All right. Yeah. So this part. Yeah. You need to write a JavaScript code. Yeah. All right. Yeah. Then that's the front end change. Then the back end. Then so the user can enter the data for 4 rows. Yeah. Each row, valid. So you can assume the valid values. Yeah. All right. Here, I didn't mention the data validation, because data validation, so some of you may ask, if the user does not enter valid data, so in the real world applications, you need to do the data validation, checking part. Yeah. So this one, I didn't mention that, so I do not require you to do the data validation. So that's optional. If you want to do it by yourself, that's good. If you skip it, no problem. Yeah. Because that's the extra work. Yeah. So I want to, reduce the workload. Yeah. So I didn't talk about data validation here. Yeah. All right. So you can assume you enter valid data. Yeah. Then click Enter button. So the data of all the rows, you need to send it to backend PHP processing file. Yeah. So the PHP processing file retrieve the data of 4 rows, then prepare insert statement. Yeah. Remember, we use multi-row insert version. Yeah. So you make one insert statement containing the data from, in this example, 4 rows. We know separate by comma, right? So that one insert statement, yeah, containing 4 rows of data and separated by comma. Yeah. That format. Yeah. So you prepare the string insert statement, query value. Yeah. Then, so you execute, you run that insert query. Yeah. So you get all the rows inserted in one insertion operation. Yeah. So that's the main feature you need to implement. Yeah. So for the whole project, so this is the main feature you need to implement. Okay? Yeah. All right. Other than that, other features all provided in the sample code, in my sample code. So it's there. Yeah. So you just, learn the code. Yeah. Yeah. Understand the code. Yeah. But if you want to write your own code, that's okay. Yeah. 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 But you get my sample project, so you can do faster. Yeah. So you can get to the point you need to write your new code faster. Yeah. All right. Then next, editing rows. This part also, I provide you with the sample code. Okay. Yeah. Yeah. Update. Yeah. Sample code. Yeah. Delete, also sample code. Yeah. 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 So do not, yeah. So update, delete, also in sample code. Yeah. All right. Yeah. And generating a report, also available in sample code. Yeah. Yeah. The transcript. Generate the transcript in this format. Yeah. Yeah. Available in sample code. Yeah. All right. Then I want you to do some practice using this Ajax technology. So I give you a small Ajax feature example. Yeah, here also included in the sample code. Okay. All right. Yeah. So you can see, although the description is long, containing a lot of features, but you only need to write your code for this feature number 3, a multi-row insertion. Okay. Yeah. So for other features, you just study the sample code, understand, to get you, get yourselves familiar with the PHP programming quickly, yeah, in our limited amount of time. So then, try to speed up your learning process. Okay, yeah. Otherwise, if I ask you to, write the code for all the features, although it's a good experience, but we don't have that much time. Okay. Yeah. Yeah. Because we need to do a lot of work on the database query. Yeah. That's our main part of the work. Yeah. Yeah. So do not get scared by this project. Okay. Yeah. When you look at the long description, some of you may get scared. Yeah. But after my explanation here, so yeah, not too much work. Yeah. All right. Then, because for some of the students, so they may, yeah, some of students, because they're familiar with, all these web programming, PHP coding, yeah, they have that experience. Yeah. So they may like to do more than the standard requirements. Yeah. So then I provide a optional optional feature, add a batch input from a CSV file. Yeah. Batch Yeah. So I explain the batch insertion. So the data comes from a text file, CSV file, yeah. Comma separated values, yeah. Because in real world applications, this method is used a lot. Okay. Think about if sometimes people prepared, for example, relatively large number of rows of data. Yeah? Yeah. So the non-computer programmers, the non-computer programs, they can, use a text file to collect a certain number of rows of input data, yeah, organized, separated by comma. Okay, so row by row, each row, data separated by commas, yeah, then multiple rows, yeah, but relatively large, yeah, so not a 6. So here because when you ask the user enter manually, so that number usually should not be too large. Yeah. Too large, then the user won't feel comfortable. Okay, yeah. But the text data in a text file, then you can put a large number of rows in a text file. Okay, yeah, yeah. Then you need to use upload. Yeah. After you prepare the data following the format, right format, yeah. CSV, yeah, that format. Okay, yeah. Each row, make sure the order of the fields correct. So do not change the order. Okay, use the natural order of the fields. Yeah. All right. So then you use the upload feature. Yeah. Upload feature. Yeah. So you go to the W3 School PHP section tutorials. Yeah. So you can find how to do upload. Yeah. Sample example. Yeah. You can find a very simple example. Yeah. Upload. How to upload the text file. Then you need to, after in your PHP data processing part, yeah. So you need to access the data in the uploaded file row by row. Every time you read one row, yeah. After you do one row, because the data fields are separated by commas. Yeah. So you can use comma as the delimiter to split the data. Okay? Yeah. Then you prepare your batch insertion statement. Yeah. So here we can assume the number of rows in this text data not too large. Okay? Yeah. Reasonable number, not too large. Yeah. Yeah. Remember our batch size. Each batch we can enter 1,000 rows. Here we do not assume you need to prepare for the number of lines more than 1,000. No, we assume the number of lines we expect less than 1,000. That means one batch is enough. So when you prepare your batch insertion, the statement, assume you just do one batch. Okay, yeah. Not more than one batch, just do one batch. Okay, yeah. All right. Then, so you write your batch insertion code, implement, successful, you get another version of multi-row insertion, but by the CSV file and using the batch insertion. So that's the optional feature. Okay, yeah. So only for the students, those students, they already have the experience. Okay, PHP programming experience, so they can write the code immediately. Okay, yeah. So if they use my sample code, yeah, so they can quickly get to the point. Yeah. So they need to implement the new features. So then it does not take long for experienced programmers, so they can get a standard feature quickly. Then, because they want to do a little more work, so here there are 2% extra credit. 2% here means overall 2%. Okay, So because some of you may ask me, what do you mean 2%? Overall, because we know the total grade, the percentage for this class at the end, final, 100%, right? But that 2% is, use that 100%, you add 2% extra, okay? On top of that 1%, then add another 2% on top of it. So it's pretty good. So I expect small number of students, so they may like to try this option. Now, if you have extra time, extra energy, and you do not feel this project too much work, so those students, you can take this, try to get 2% extra credit. All right, so that's pretty much I want to explain about this project number 2. The sample code, so in each class, I give you one portion of the sample code, covering a few features. So then I explain a little bit. Okay, and after I do it 3 or 4 times, so then you get everything you need. All right. Any question? Oh, I see one chat message here. Let me check it. Where can find? Sample code. I upload. So you remember our first sample code, that university view. So I treat that as a sample example. The first one, you got it. So then the second one, today I do not give you the second one. Okay, so today I want to explain the university view. So starting from next class, so I will give you the edit part, feature editing part. Okay, editing, single row, edit, that's always single row. So I will upload. So the part C of module 5, so after the notes, I upload zip file of the sample code covering editing part. Could share when this project, the project is due. Do you see, so this is due date after the final, okay? September 15th, the Sunday after the final. So we have a final week, right? So there is one whole week. After Thanksgiving, we have 1 week time, to prepare. We can do review for the final. 1 week, 2 classes. After that review week, then it's the final week. So you need to, come to the classroom. So we have the specific time. Final. Okay, but the deadline is after that final day, that Sunday. Okay, that Sunday after that final exam. That means after the final, you still have a few days. But I hope you can start as early as possible. So do not delay too much. At least you need to understand my sample code. Okay, and when you write the code here. Yeah. So the main feature you need to implement here. So you may, if you do not have idea, so how to do this, you can ask me, right? Yeah. Yeah, because you need to use JavaScript to modify the user interface. Yeah. For some of you probably, so because if you do not have a lot of experience using JavaScript, so you may feel a little hard. Yeah. So if you need my help on that part, so I can explain, yeah, that part. Yeah. But I hope you can find a solution. Yeah. First you try to find solution by yourself. If you feel too hard for you, then I will help you. Okay? Yeah. I will find a way to help you for that part. Yeah. And I can explain the ideas, so how to do the whole thing. But I want you, really, you write the code by yourselves for this main feature. Yeah. 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 Because you need to, at least you need to do something, right? Yeah. Yeah. At least you need to do some meaningful work. Yeah. Says that's my goal. Okay. For the second project, I try my best to reduce your workload. Yeah. But you need to do some meaningful work. Yeah. For the second project. Yeah. So that's my point. Okay. But definitely, when you have any question about the programming, so I will explain. Yeah. Yeah. I will give you ideas. So how to do this, how to do that. So if you need my help, yeah. Yeah. Otherwise, you search the web, find the suitable examples, and then you write your code. So that experience. Yeah. All right. Yeah. So that's the plan. Okay. Yeah. Think about it. Yeah. Try to understand, about this project. Yeah. Yeah. So then, because in our notes, I explained this multi-row insertion. I also explained the batch insertion. So that part of the knowledge, here we practice that part. Okay. Then CSV, yeah, I also talk about that. Yeah, CSV batch file. Okay. Yeah. So the interesting features, you may need to use in the real world applications. Yeah. All right. Yeah. So that's but at the same, the reason I provide a lot of sample code, because based on my experience, many of our students, so actually they do not have a lot of web programming experience. Yeah. So I try to, consider the needs of those students. Yeah. So do not make those students do too much work. Yeah. All right. Yeah. So let me know any help you need. Yeah. So I will, get ready. Find a way to give you help. Okay. All right. So that's this topic. All right. Next. Yeah. Let me save this file. Then I will upload. Yeah. So this file with annotation. So I will upload. So so you want to, look at this file. So you can see it. All right. Yeah, because we already from the remaining amount of time. Yeah. Yeah. If I explain this, I prepared the code ready here. Yeah, if I explain, so I may not be able to complete the second half of the part B. Yeah. So let me move to part B first. Yeah. Because this part, I try to find some different time. Yeah. If you can understand, that's good. Yeah, but still, for some beginner students, yeah, I feel I should explain this code. Okay, my logic. Yeah. So why I do it in this way, in that way, different ways. For beginner students. So yeah. Although I can use video to explain, yeah. So I have options. Yeah. If I couldn't find class time, then I will make video to explain this code. Yeah. All right, but the second part, the editing part, I will give you in next class. Yeah. Edit, update, edit, so that feature. So the transcript, I will give you another class later. Transcript, Ajax, another class. Yeah. All right, so now I want to move to the second part, of this indexing topic, second half. I try to complete, so I have 40 minutes. So I try my best to complete because I have 4 slides. 4 slides, so each one 10 minutes. So I have a chance to complete it. All right. So this is the last slide we did the last time. So let me review a little bit. Recall. So get to, it's a lot of things here. But let me refresh your memory a little bit. Here the topic, how indexing works, the basic steps. All right. So here the bottom part, I explain the details about disk block. So how we store a unit of data. So data storage unit. So one block, one unit. So why this one unit? So this unit, because every time when we load the data from hard drive into main memory, we need to load, right? From hard drive to main memory. So we need to load unit, block by block. Block by block, we load it. Okay? All right. So what is the size of one block? The size, can vary, but the most commonly used the block size. Here, let me give you the block size. The most commonly used the block size. 4 KB, kilobytes. 4 KB, 4 kilobytes. Okay? That's the, most popular block size. 4 kilobytes, not too large, right? That's not too large. And not too small. So one disk block can contain multiple records, right? Because when we store data of tables in records, row by row. So one block, so usually we can store, certain number of records, one block. So every time, because if the data is stored on the hard drive, we know access data on the hard drive very slow, right? Access data on the hard drive, very slow. And then, in order to make data access faster, so we need to load the data from hard drive into the main memory. So every time we load one disk block into the main memory. Okay? Or multiple disk blocks. Okay? All right. So then we do the search. We do that. All right. So then, after you understand the disk block, so from the diagram, I talk about several concepts. The cylinder and the disks, each disk surface two-sided. So we started a two-sided. Then on one disk, tracks, concentric. There are a sequence of concentric tracks. Okay. Then we use sectors to divide those tracks. Sectors. Okay. All right. Then in each sector, there are multiple disk blocks. Yeah. So that's structure. Yeah. Then let me repeat this, how to find a record in a table. Yeah. The standard process. A search condition based on a field, a where clause. Yeah. So you specify some search condition in the where clause. Okay. All right. Yeah. And we assume an index file is created based on that field, based on this field, index file available. Okay. Yeah. Then the first DBMS search the index file. Yeah. The auxiliary, the index file. Yeah. So what's the index file? Index file has the structure. Yeah. Index file is small table, not original table. Okay. Yeah. Much smaller table. That smaller table only contains two columns. Okay. All right. So the first column is the key, search key. Okay. Yeah. Search key, the key field. Search key field. The search key corresponds to your indexing field, right? Because you need to select the field for your index file. Okay. So that selected field, you use that as the search key. The second column, you use pointers. Okay. Yeah. The value in the second column, corresponding pointers. Okay. Yeah. Point to the disk location. Yep. So disk block location. Actually, each pointer point to one disk block on hard drive location. So the disk block, a pointer to a disk block. That block contains the original requested data. Okay. Yeah. Yeah. So first you use the binary search to search the key field. So use the binary because it's sorted, right? So the first column, the key column, it is sorted. Yeah. Yeah. DBMS apply sorting operation on that key field. Okay. Yeah. Search key field. So you get ordered search key values. You can apply binary search, so you can find the right place, search key. Then, after you find the right search key, you can get a corresponding pointer, that location. The pointer point to the hard disk block, that location. Yeah. Then, when you load the data, you just load that whole block from hard drive to main memory. Yeah. Then you search that block in main memory to find the record you need. That's the whole process. Okay. Yeah. So this slide tells us that whole record search process. Yeah. From hard drive, then loaded into the main memory, then find the requested record. Okay. Yeah. Yeah. All right. So that's here. This is the general description. General. Yeah. But later, we want to see some variations of this general process. Variation because we have several different types of indexes. We have several types of indexes. For each type of index, so we need to modify this process a little bit. Yeah, this general process for different index types. Yeah. All right, so now let's move to the new part, B.3, primary index. This is our first index type, primary index. Now, this index is used, most of the time. 90-something percent, 90-something percent, you use this primary index. Okay, then the remaining small percentage, several other types. Yeah. So first we understand this basic index type, primary index. All right. So what's the structure of the primary index? So here, let me describe it. All right. An ordered file whose records of fixed length with two fields, a key and a pointer. Yeah. So in the previous slide, I already described a little bit. Yeah. So our primary index takes that structure, that format. Yeah. Actually, other types of index also take this structure, but inside the keys. So how do we choose keys? Then there are several variations. Okay? Yeah. How do we choose keys? Yeah. So for different type of indices. Yeah. So we use different ways. Yeah. So the details is inside, keys and the pointers, keys, how to choose. Yeah. All right. So order the file. Yeah. So we need to sort the key fields. Key field. Yeah. All right. Fixed length. Yeah. So here, let me draw the diagram again. All right. In order to help you understand the whole thing better. So this is original table. This is original table. Okay, yeah. Usually larger table, right? Because you have multiple fields. You have many fields. Original table. All right. Then, after that, index file, much smaller table. Okay, much smaller. Yeah. Like this. No matter how many fields you have here, for the index file, you always have two fields. Okay, 1, 2. Key, first one key, second one pointer. Okay, then second one pointer. Yeah. Then multiple rows. Certain number of rows. Okay? Yeah. The number of rows here may not be the same as that one. Could be different. Yeah. So depends on your index types. Yeah. So we will get there. Okay? All right. So each row, you have a row, right? So each row we call it entry. Index entry. Yeah. We call it index entry. One index entry. Yeah. So you have two values, key value and the pointer value. Pointer, that's the location. Disk block location on the hard drive. Yeah. So that's entry structure. Yeah. All right. So you can imagine fixed length, right? Yeah. The key value, the length, and the pointer, number of bytes, key field, certain number of bytes, all entries, all the entries, they have the same, occupy same number of bytes. So we say fixed length. Okay, fixed length here means for the entry. All those entries, they have fixed length. Yeah. Fixed the number of bytes. Yeah. We use. All right. Primary key of a primary index. Yeah. So here we're talking about primary index. Yeah. The structure of primary index. Then this first key field we call the primary key. The primary key of the primary index. Yeah. All right. So then I hope you do not get confused. Yeah. Because in our SQL table we have a primary key concept, right? Yeah. Yeah. So here, two meanings. All right. One meaning is in SQL table. You have that primary key. Okay? You know that primary key concept. But here, the primary key here, the meaning is different. The primary key here is in primary index. The index type. Index type, you know, this key, so we call it primary key also. All right? So do not get confused. You need to look at the context. What is the exact meaning of that primary key? Okay? Yeah. Yeah. All right, so this point, very easy to get confused. The primary key meaning. So here we need primary key of the primary index. Okay? Not the primary key of the original table. Okay? The original table may not have a primary key, right? Yeah. Even if it has a primary key, but we may not use the primary key of the original table as the primary key of the primary index file. So that's different. Yeah. Yeah. So that's one thing. Yeah. Yeah. So what its meaning? The first field is of the same data type as the ordering key field of the data file. Yeah. Because for example, if we use one particular field in original table to create a primary index, okay, use this one. Then this key values we use as the primary key in the primary index. Okay? Yeah. That the values of that column. Yeah. But next you will see we may not use all the rows here. For primary index, we only use part of the rows in the original table. It may not be all the rows. So that's a special property of the primary index. Yeah. So we will get there, that property. Yeah. So that's why I mentioned the number of rows here. Suppose there are n rows in the original table. Here there are m rows. Okay. Yeah. Those two numbers, you know, in general, it's different. Actually, n is usually greater than m. Yeah. Because we only take part of the rows in the original table to create our primary index. Yeah. All right. The second field is a pointer to a disk block that contains the record to be searched for. Yeah. So that's the, you know, saying as mentioned in the previous slide. Yeah. But we need to focus on the first field. So how do we select the entries, you know, first field values for the entries in the primary index? Yeah. We need to focus on that part. All right. Number of index entries. Yeah. Then, yeah. Let me explain. Yeah. How to make the entries of the primary index. All right. there is one index entry in the primary index file for each block in the data file. All right. So look, let's understand this sentence, the meaning of this sentence. Okay. Each block in the data file, what's that? This data file means the original data file. Okay. Original data file. All right. Yeah. Now this time, we need to draw the diagram describing the original data file. Yeah. Suppose this is original table. Okay. A relatively large table. Okay. Many columns. All right. Yeah. You need to store on a hard disk, right? Hard drive. Yeah. Store on hard disk. Hard disk. But when you store hard disk, remember you store in consecutive disk blocks, right? Consecutive disk blocks. Consecutive disk blocks. Okay? Yeah. All right. So here, let me enlarge one of the disk block. Yeah, so this is the concept. Disk blocks. Then let me enlarge one of the disk block. Okay. Suppose this is one disk block. One disk block. All right. In one disk block, we imagine we can store multiple rows of the original table. Okay? Multiple rows. Okay? Row 1, row 2, row 3, row 4. Okay? So usually one disk block can hold multiple rows of the original table. Okay? All right. Then, what is the block address? One block should have a block address, right? Block address, that's the location of the first row. This location, it is the block address, first row. Yeah. Next slide, we will learn the concept. We call it, anchor. Anchor of this block. Yeah. Anchor. This row record. Yeah. All right. So then, the pointer, the entry. So here, there is a index entry in the primary index file for each block. Each block, you only use one primary index entry. So one entry takes care of one disk block. Okay? Disk block. Yeah. Because one disk block may contain multiple records of data. Okay, so here I write the data, original data. Okay, you just understand the original data. Yeah. All right, so here you can see multiple records of original data. We only use one primary index entry, we can cover the whole block of original data. So that's the reason the number of entries in the primary index is much smaller than the number of rows in the original table. Okay, all right, yeah, so that's structure. Okay, then anchor record. Yeah, so I just mentioned. So now you know the anchor record in the primary index. Yeah, because the pointer of each entry needs to point the anchor record in each block. Anchor record. All right. Each index entry has the value of the primary key field for the first. So what's the anchor record? What's the anchor record? First record in the block. That's the meaning. Okay? Use it as the anchor. Yeah. Yeah. All right. Yeah. Key pointer. Yeah. So that pointer pointing to anchor record of each block. All right, yeah. So each disk block usually contains multiple records. Yep. So I just drew the diagram in the previous slide. Yeah. All right. So it is called an anchor record, the first one, the location of the first row in each disk block. So we call it anchor record. So a primary index only stores the field value for block anchors. Block anchors. Non-block anchors, we skip. Okay? So we do not create index entries, when we use the primary index type. Yeah. So we skip those records. Non-anchor record, those records. Okay? So each block, we just take a representative. Yeah. Anchor record as the representative. So then we use the key of the anchor record to create a primary index, the key field part of the primary index. That way. Okay? Yeah. All right. So then the total number of entries in the primary index is the same as the number of disk blocks in the ordered data file. Yeah. So here, yeah, this probably may get confused, Yeah. Because we know the original data file, there is no specific order, right? No. Because it's not ordered. Original data, not ordered. Yeah. But here, why? So here, use this ordered. Yeah, actually, the disk blocks occupied by the original data, that disk blocks ordered. Yeah. So in a occupy consecutive locations on a hard disk. Yeah. That way, I think it should be that meaning. Yeah. Because original data, we never assume original table. The data in the original table is ordered. We never assume that. Okay? Yeah. But when we store the data in the original table on a hard disk, one table occupies certain number of disk blocks, right? Yeah. So the disk blocks occupied by one particular table, that's the consecutive disk blocks. Yeah. So the block addresses for the occupied blocks must be consecutive locations. Yeah. Then, for the search, then it's easy to do. to do the search. Yeah. Otherwise, if it's not a consecutive disk blocks, so it's very hard to do the prediction. Yeah. Consecutive, then we can do the calculation. Yeah. So we can, based on the address value, we can quickly, go to the right place. Yeah. Yeah. All right. So this number is usually smaller than the number of records in the original file. Yeah. Usually, yeah. So that means most of the time, but not 100%. Not 100%. Yeah. Because think about, sometimes one record could be very large, right? Yeah. So there are certain situations. One record could be very large. One record can occupy multiple disk blocks. That could happen, right? Yeah, that could happen. Yeah. Yeah. Although the percentage wise, it's very small, but it could happen. Yeah. So that's why we say usually. Okay, usually. Okay, most of the time. Yeah. So one disk block can hold many records. Yeah. Certain number of records. Yeah. All right. Yeah, so let me look at how much time I left. Oh, yeah, 10 minutes left. Yeah. I don't know if I can complete it. Yeah. Then performance of primary index. Size of a primary index file. So we can do the calculation. Yeah. Yeah. But for this class, we won't do the calculation. I remember several years before the COVID, then for this power material, I did a lot of computation. Yeah. So the students will, given many computation questions, and some questions pretty hard. Yeah. But, after the COVID, so then I skipped the calculation part. Yeah. Yeah. All right. Just to give you some background knowledge. Yeah. So there are fewer index entries than there are records. Yeah. That's the general case. Okay, yeah, the general case. Yeah, yeah. All right. Each index entry is typically smaller in size than a data record because it has only two fields: yeah. The key field and the pointer field. Yeah. More index entries than data records can fit in one disk block. Disk block here we mean. Yeah. Yeah. We mean disk block. Hard, we're talking about. All right. Yeah, because the entry size is much smaller than the record size in the original table. Yeah. Okay? Yeah. So then you do division, yeah. Your disk block size, you do division, divided by the entry size, that number should be larger. Then you do division, the block size divided by the record size, that number much smaller. Yeah. Yeah. Then binary search. Yeah. So the index file, primary index, when we look at the key field, all the values for the key field must be sorted, okay, ascending order. So we can apply the binary search. Yeah. So for the binary search, then we have a formula. How many comparisons do we need for the binary search? If you know the number of entries in the primary index. All right. So here, the performance. Yeah. Number of comparisons in your binary search for the worst case. So we have the best case, we have the worst case. Here I give you the formula for the worst case. That is seeding function of log base 2 of n plus 1. Yeah. Here this n means the number of entries in the primary index. Number of entries. Yeah. Okay? Yeah. This is the worst case. Yeah. We can only do better than this one. Yeah. All right. Yeah. All right. But this is the single level. Yeah. Remember, we have multi-level tree structure. You know, this number corresponds to the single level. Okay. Yeah. If we use multi-level tree structure, then the number much smaller. We can make the worst case, the number comparisons, much smaller. But we organize data in the multi-level tree structure. So the data structure will be much more complicated. Okay, yeah. So later I will mention a little bit, but I won't give you too much details about the tree structure. Yeah, because we won't have that much time. Okay, yeah. Just to give you some high-level description. Yeah. All right. Then the last slide, binary search-based indices. Yeah. Yeah. Last slide, so we can complete today. Yeah. This, you know, part B. Yeah. Binary search. Yeah. Based index. Yeah. Ordered files. Yeah. A table can be sorted on some index field. Yeah. So from the original table, we select one of the fields, and we create index. Yeah. So then, the index file for the key field. So we sort it. Yeah. All right. Yeah. An index file is created, and the index entries are sorted in order to apply the binary search. Yeah. So the DBMS does this part. Okay. So you do not need to do anything. After you create an index, so then the remaining work is done by the DBMS. Okay. Yeah. You know. Yeah. You just, you know, do your normal search. When you do your normal search, so your query, you know, where, yeah. So then it will be faster. Yeah. Where the data size is large, if the data size is very small, so then not worth it, right? Yeah. So then if you create index, so because a lot of overhead. So at the end, you may not get a faster performance if your data table size is not that relatively small. Okay, yeah. So relatively small, then we do not use indexes. Yeah. Only when we have relatively large table. Okay, yeah. So when we can use indexes to speed up the search. Yeah. All right. Then a few more lines. If both the data file and index file are ordered, yeah. So in some very special situation, the original data file could be ordered, yeah. But that percentage is very small. Here we just compare the performance. If the original table is ordered based on a particular field, yeah, because we can apply the binary search directly on the original table, right? Yeah. But we have an option. We create an index file for that particular field. Then we compare the performance of these two ways. Yeah. So here, why using index file? It's still faster. Yes. Yeah. So here it tells us even in that ordered data situation for our original data, the index was still much faster. Why? The reason is very simple. So usually original data file has more fields, yeah, more columns. So yeah, then the table size much larger than the index file size, right? The table file size much larger. If it's much larger, then each disk block can hold much fewer number of records, right? Comparing with each disk block, the number of entries that each disk block can hold. That number, the difference is quite large. Yeah. So then you apply the binary search, your index file is much smaller, right? Yeah, much shorter. Your original file, much larger. When you apply binary search on a very large file, then it should be much slower when you apply binary search on a much smaller index file. That's the meaning, okay? That's the point here. Yeah. All right. So an index file has only two fields, key and a pointer. And a larger file uses more disk blocks. Now, more disk blocks, so when you do the search, among large number of disk blocks, you need more disk access, right? More hard disk access. But if you work on much smaller index file, then you can greatly reduce the number of hard disk accesses, right? We know hard disk access is very slow. So here it tells you, even in that special situation, order the original file. So order the original file. Even in that special situation, that percentage is small, but even that situation, index file way still much better. Okay, still much better, much faster. Yeah. All right. Oh, yeah. We run out of time, but we also finished the last slide. Okay. Yeah.